Hello. This video I am making for my young colleagues who teach engineering mechanics. Although I use the word young, I am aware that some of them are more experienced in teaching engineering mechanics than I am. But nevertheless, taking advantage of my age, I wish to give them some tips. And this is regarding how to deliver the first lecture on engineering mechanics. But this is my humble suggestion. They need not accept it. They might have better ways. Now, one often problem with conventional teaching is that the way the lecture is started is generally failed to stimulate the minds of students, and that becomes really boring. For example, when somebody enters in the class and they said keep quiet, and today we are going to discuss or study this topic, and then while you say this, while the teacher say this, and teacher would turn their back towards that students, write the title, and while writing the title they will repeat that. Now that's really very drab, that's really boring. So how do we start? And especially when you are going to introduce a subject such as engineering mechanics, highly conceptual subject, how do we start? And I have realized that the best way to start is with something with which the students are familiar, and bring in some surprise element into it. And that surprise element is in their lack of clearer understanding of three laws of Newton. Now, so I would say that the teacher should enter the class and the teacher should say that we are going to start engineering mechanics, but the foundation of course is of Newton's laws, and we have been taught Newton's laws for many years. And then you can throw a question, when were you taught Newton's laws? Then there could be interaction. Some would say 7th standard, 8th standard, 9th standard. So you give that time, let the students think about it, recollect it, and then you say that of course that means you must be sure about that. And most of the students will say yes, they are sure, they have understood Newton's three laws. And you could say that you may not give the clear statement, but you have understood it. And then they have become all the more confident because so they say that yes, we have understood Newton's three laws. And then now that's the starting point. Then you say that I would like to test your understanding of Newton's laws, and ask them to state first law of Newton. And many hands would be raised, or some hands would be raised, because statement is it's a challenging statement, in the sense they would struggle to remember the exact word. But so ask them to state. So the correct statement obviously is that a body which is under the state of rest or of uniform motion will continue to remain so unless it is acted upon by an external unbalanced force or net external force, right? Now this is the correct statement, but students invariably will forget to mention net external force or unbalanced external force. They might also forget uniform motion. They would say just motion, state of rest or motion, okay? So there would be only one or two students, right, of the many hands. They might have correct statement, and ask them to give the statement and ignore the correct statement, because we want wrong, and because majority of the students don't pay attention to these two words, but basically uniform motion and external, next is unbalanced or net, both are same. That word is they miss, and we have to harp upon that. So select a wrong statement, and then then give an example. Let's say that, tell them that imagine a plane moving, although it looks like a fish also. Imagine a plane moving in a particular direction at constant speed. That means essentially you are saying it's uniform motion or constant velocity. But don't say constant velocity or uniform motion. Say that it's moving at constant speed and in a fixed direction. It's not changing its direction. Okay. And then say that, look, you have just told me that it's under motion, and it will continue to remain so unless acted upon by an external force, because they have not used unbalanced or the word net. And then ask them, aren't there external forces acting here? Of course there are external forces. Ask them which external forces, and let them think. So, and you can say that, see, the gravitational pull is downward, but the plane is not falling downward. So this first force acting downward, there is external force, but there is engine generates an upward thrust which is balancing it. So that's another force. Then you can say that this plane is moving in this direction, so air is offering resistance. So we can say frictional force is towards right. That's also an external force. And obviously the engine is moving ahead, so it is overcoming the friction. So then ask them, there are so many external forces, and you said that there is and the body will continue to be under the motion unless acted upon by an external force. And that would surprise them. It would take a lot of time. Again, as I said, 2-3 students will raise their hands, they have the answer, and mostly these are the students who have prepared for joint entrance exam, JEE exam, and their concepts are made clear. So apart from that, I have not come across students who have clear understanding of this. And then after, let them think for a while and then tell them that what they have missed. They have missed unbalanced force. So in this case, all the forces are balanced. There are external forces, but they are all balanced. There is no unbalanced force, right? And if there were unbalanced force, then this body would not have been under uniform motion. And you should tell them that Newton's first law talks about uniform motion, right? That means constant velocity. That velocity can also be zero, right? But it should be constant. And if there is external unbalanced force, this cannot be in constant velocity, it will be accelerating. Now that's what we should bring out. So Newton's first law, students will definitely miss. 90% of the students forget the word net external force or unbalanced external force. They might just use force or external force, but not this net or unbalanced, and bring out that. Okay. Then come to second law. And ask them what is the Newton's second law, and then they would say relationship between F and ma. Ask them what is the mathematical statement, and they will say F is equal to ma. Okay, so F is equal to m into a. Fine. Then ask them what is F, they will say force. Ask them what is a, they will say acceleration. Ask them m, mass. They'll right. But here also they have made a mistake. This F, often they don't have in mind that this also is again net force, right? And they have missed that point. So again, come back to this example, and you say that F is equal to ma. Okay, so here this plane, as earlier, acceleration was 0, right? So because velocity is constant, we said if acceleration is 0, then F is equal to ma. Here right hand side is 0, so F should also be 0, but F is not 0. And then make them think, and again bring home that point that even in F is equal to ma, F is sigma F or F net. Now that's very, very important. I am telling it at a you would sense this surprise in them. How come they miss it? Okay. Then comes very interesting point. Then comes talk about Newton's third law, and you can say that Newton's third law is something, even if you are after 20 years from now, if you are woken up at night, you would immediately, and you are asked what is Newton's third law, you will, like a puppet, you would say that like a parrot. You would say that action and reaction are equal and opposite, right? And every student would agree with that. It has been part of our system. Okay, so then you can ask very interesting question, and I generally ask them this. So this, I'll say that on the this is a duster, I apply a force through the chalk, and the duster moves. Okay, and then I say that why should duster move? Because you have just told me action and reaction are equal and opposite. The chalk is applying force on the duster, there is a reaction, and that should be in opposite direction and equal in magnitude. So action and reaction should cancel out. Okay, and then the duster should not move because there is no force is cancelled out. And ask them, that means our understanding of third law is wrong, because actually the body is moving, but if action and reaction are equal and opposite, the forces should have been cancelled. So what is the lack in understanding? You can further develop it, and the way I do it like this, right? I will say that this is say the duster, this is the chalk, force is here, the reaction is here, and I will say I'll draw equivalent figure, and here I am doing a mischief, and we should tell the students later that it is a mischief we are doing. I mean, we are deliberately misleading. This is a point, this is an action, and this is a reaction. Say that this is equivalent. Isn't it equivalent? They might say, many of them would say, very rarely students point out the fallacy. And we say that, yeah, so this body, if there are two equal and opposite force, this will not move. So why this is moving, right? And there, now obviously the thing is, what students have missed, and unfortunately, except in some good books, Newton's third law, there is a second statement which is not mentioned. Action and reaction are equal and opposite. Action is on one body and reaction is on another body. So there is no meeting point. So there is no question of they getting cancelled. Now that definition, that's law comes in Resnick-Halliday, that book. But otherwise, it's generally action and reaction equal and opposite. But that doesn't. Then students have wrong understanding. So here you can say that this figure is not equivalent to this, because here this is the duster, there is action. On the chalk, this is the chalk, let's say, there is reaction. So one force is here, another force is here. How can they cancel out? And here I am showing as if there is one point on which two forces are acting. They are not acting like this. It appears like this, but it's not so. The force is on this body, the reaction is on this body, so they don't cancel out, right? Now, explain that. And that's very important, because then you can introduce the free body diagram, okay? So I think once you deliver this lecture, students will get surprised and they get excited. I mean, they are surprised that how come they miss Newton's three laws. They were sure of having understood them perfectly, but they have missed it, right? The central concepts are, important concepts are missed. Okay. Now, what could be done next? Now, this will consume, I think, your most of lecture, 3/4 of lecture, and full lecture. But what you should do next, in next lecture or remaining lecture, depending on how much time, I think I would say that spend a lot of time on this. I spoke hurriedly in short time, but you can, in the classroom, you can make it more interactive, etc. So then go to Khan Academy, and in Khan Academy there are wonderful MCQs on Newton's three laws. So, and they keep on changing. And I have done videos on that. So what I do is I didn't use Lernico, but because Lernico was yet to come, but I used to project on slides those MCQs, and they test precisely this understanding, and they are really brilliant questions. So now if you do this, right, instead of starting directly with statics and resolution of forces and saying that mechanics comprises of statics and dynamics, that becomes boring. Start with this, stimulate the students, and then make them do this exercise of Khan Academy, and I'm sure this would be a really well beginning of this fascinating course of engineering mechanics. Again, this is a suggestion, this is an appeal. You might have some interesting way of starting it, but my experience tells me that this is very interesting. You can decide. Thank you.